Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is adjacent sums. The problem difficulty is easy and you need to know dynamic programming as prerequisite to solve this problem. Let's have a read at it. We have an array A of size n where n will be greater than or equal to 2. This will contain non-negative integers and it will be called good if all of the following conditions are held true. The conditions are that a1 and a2 is equal or a1 is equal to 0, an is equal to an minus 1 or an is equal to 0, or ai is equal to ai minus 1 plus ai plus 1 or ai is equal to 0. Less formally, we just need to make sure that all non-zero ai is equal to the sum of its adjacent elements. Now, we are given an array A of size n consisting of non-negative integers. In one operation, we can add one or subtract one from some elements in A. Now, it is not allowed to make the element in A negative at any point. Now, we need to find out the minimum operation to make the array A good, and it can be proven that it is always possible. So, for the input format, we have t test cases, and for each test case, we have two lines. The first line will contain the integer n, that is size of our array A, and the second line will contain n space integers, that will be a1, a2 till an. As for the output, in a single line, we simply have to output the minimum number of operations required to make our array A good. As for constraints, number of test cases will go from 1 to 10 raised to 4, length of the array will go from 2 to 2 into 10 raised to 5, and value of elements can go from 0 to 10 raised to 9. Let's see some sample inputs. Let's have a look at this sample input. Here, we have three elements in our array. The elements are 2, 2, and 1. Now, if you see, when we are talking about the first and second element, either they have to be equal or a1 has to be equal to 0. Now, we can see that both of them are equal, so this satisfies. The next is an and an minus 1 should be equal to 0, or sorry, it should be equal or an should be equal to 0. So if you see, the last element is not 0 and it is also not equal. So second condition is failing here. As for the last condition, we can see that ai can be equal to ai minus 1 plus ai plus 1, or ai can be equal to 0. This is for all ai's that are between 1 and n, that is greater than 1 and less than n. This only applies to this central element, and if we see, 2 is definitely not equal to addition of 2 and 1, that is, this is not equal to 3. Now let's see what can be done. Can we delete this? That is, we know that the operations that we can perform, we can subtract or add the elements. So what would happen if we subtract this element 1 and make it 0? Now if we do that, this will look something like this. Again, if you remember, the first condition is that first and second number has to be equal, that is satisfies. The second is that last and the second last element should be equal, or the last element can be 0, that also satisfies. And finally, it says that for middle elements that are greater than 1 and less than n, this should be sum of the previous element and the next element, that is 2 and 0, and it's exactly 2. So it took us just one operation, and as you can see, for the fourth test case, 1 is the answer. Let's see how we can approach the solution. As we have seen, there are two special cases for the first and second element, and finally for the last and second last element. Now the condition is that either they can be equal, or the first element can be 0 or the last element can be 0. And for the third condition, we are saying that for these middle elements, this has to be equal to the sum of the previous element and the next element. So it's good for us if we can make something like this. We can have 0, we can then have x elements, and then we again have 0, right? So if you see, the first element we are making as 0, the last element is 0. So first and second conditions will be satisfied. And for the middle condition, we can see that this element is always sum of previous and next. Same goes for here. So whenever we are at the ith element, we are having two choices. Either we can decrease it to 0, right? Or we can make it equal to its previous element, that is ai minus 1. But when we make it equal to the previous element, we also need to make sure that the element before that, that is ai minus 2, is also equal to 0. So as can be seen for this ith element. For this, to satisfy the condition that we have seen, it should be equal to its previous element, and the element previous to this has to be equal to 0. So at any ith element, these are our choices. So let's see what is the cost. So for the ith element, if we simply choose to make it 0, the cost is nothing but ai. Then if you goes to follow the second path, the first cost would be the absolute difference between the element and the previous element, right? Next, since we want to make the element previous to this, ai minus 2, to be equal to 0, this will be the cost. So what we can do is we can simply do a dynamic programming for all ith element. Whenever we are doing this, this is the cost, and we have dealt with the ith element. And for the previous element, we can simply do a dp of I minus 1. In this case, we'll do a dp of I minus 3. As we keep on doing this, this is the ith element. So we are saying the dp of I represents the cost to make a good array for I elements. And if we go till the end, that is the dp of n will give us the value required to make the complete array good. And this is our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and we add 3 to the n. We do this because, as you have seen, for the second option, we need 3 previous elements. We need to first make the current element equal to the previous element, and the element previous to it, we have to make it 0. Then we will check the last third element as dp. So for this, we add a padding of 3 elements. Once we have done this, we start calculation of our dp. The first element, we only have one option, that is decreasing it to 0, because if there's a single element, we can simply decrease it to 0 and get our answer. For the elements next to it, we have two choices. Either we choose to decrease it to 0, or we choose to make it to be equal to the element previous to it. If we do that, we also need to make the element second previous to it to be 0. So for that, the cost will be I minus 2. Once this ith element is dealt with, then we can simply check the dp of I minus 3. We do this and we take the minimum for each ith element, and at the end, we simply print the dp of n minus 1. This will give us the minimum cost to make the complete array good. And as you can see, I've got an AC in my C++ implementation. Let's see how we can implement the solution in Python. Again, for each test case, we call the function solve, take the input of n, then our array. We add the padding of 3 both to the array and our dp. Then we calculate the values of dp with two options. Either we make the current element as 0, or we make it same as the previous element. At the end, we print the dp of n minus 1, giving us the minimum value to make the complete array good. And as you can see, I've got an AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.